Welcome to Chapter 1 of our series, How ChatGPT Actually Works, No Engineering Degree Required. In this episode, titled The Infinite Library, How ChatGPT Learned from the Internet, we're going to explore the fascinating ways AI models gather data from the vast expanse of the Internet. So, whether you're a tech enthusiast or just curious about how these systems operate, let's dive in. Right now, there's a system talking to millions of people that has never read a book the way you do, never watched a video, and never learned a single clear-cut fact. Yet, it can summarize your thesis or draft your email. How does something that knows nothing sound so much like it knows everything? Here's the twist. ChatGPT was never taught facts one by one. No teacher sat it down and said, "Paris is the capital of France," or "Shakespeare wrote Macbeth." Instead, it was exposed to an enormous, messy dump of text from the internet. Articles, forums, code, fiction, documentation, and given a single, almost boring task. Predict the next word. Over and over. Billions of times. From that repetitive, mechanical game emerges something that looks a lot like reasoning, explanation, and conversation. In this episode, we'll peek behind the curtain, where that data likely came from, how a transformer model turns raw text into internal patterns, and why techniques like human feedback and safety training are layered on top to turn a raw text prediction engine into something you'd actually want to interact with. To really see how strange this is, focus on scale and limits. GPT-4 wasn't handed the internet. It saw a filtered, frozen slice of it, harvested before you ever typed your question. No live browsing, no secret database of private messages, mostly public web pages, licensed data, and text chosen for quality and diversity. And even that giant pile is incomplete and biased. Some languages, topics, and communities are overrepresented, others barely there. In this episode, we'll explore how those choices shape what the model is good at, what it misses, and why it can sound confident even when it's wrong. Here's where the infinite library notion gets concrete. During training, GPT-4 wasn't handed labeled facts. It was hammered with unfinished sentences and forced to guess what came next. Each guess was scored automatically. Closer to what actually appeared in the dataset, lower loss. Further away, higher loss. Billions of these tiny nudges gradually reshaped the model's parameters so that its guesses became less terrible, then passable, then surprisingly strong. Crucially, nothing inside the model looks like a row in a database saying, "Einstein, physicist." Instead, training pushes it to internalize relationships, how certain words, phrases, and structures tend to co-occur. When you ask a question, your prompt activates patterns that were carved during training, and those patterns guide the next word predictions you see as answers. The transformer architecture makes this efficient by letting the model look at all the words in your prompt at once, rather than one by one. That global view lets it juggle local details, what's being asked right now, and broader context, what topic are we in? Over extremely long prompts, it still has a limited window, so older parts may fade out of view, even if they were important. Scale matters here, but not in a just add more data way. As models grow, they start to exhibit emergent behaviors. They suddenly become decent at tasks they were never explicitly trained for, like following multi-step instructions or translating reasonably between languages present in the training mix. Researchers watch for these jumps by running standardized benchmarks, math problems, coding tasks, reading comprehension, to see where performance spikes instead of rising smoothly. Then comes the twist. Raw models can be dazzling and also wildly unhelpful. RLHF sits on top not to teach new knowledge, but to shape style and priorities. Given multiple possible answers, human labelers score which one feels more honest, safer, clearer, more useful. The system learns a preference pattern. When in doubt, explain uncertainty, avoid harmful suggestions, follow user intent when it's reasonable, push back when it's not. That's why the same underlying prediction engine can feel very different across versions and products. It's the same core patterns, steered toward different goals. Think less about intelligence and more about habits the system picked up by exposure to patterns. When you ask, write a breakup text that's kind but firm, it isn't consulting a rule book. It's lighting up regions of its internal space where similar wordings clustered during training, polite language, emotional tone, direct phrasing, then weaving them together on the fly. You can see this by nudging style. Make it sound like a lawyer. Now rewrite as a pirate. Now as a 19th century novelist. Each modifier pulls the response toward a different region of patterns, often without changing the core request. Developers exploit this by crafting prompts that act like soft settings, system messages, style guides, even hidden instructions that bias outputs toward particular domains, like coding help or customer support. One way to picture it, sparingly, is like tuning an equalizer on a sound system. The same song, but with different frequencies emphasized depending on what you want to hear. Governments and companies are quietly treating systems like this as infrastructure, routing email, drafting code, scanning contracts. That makes questions about provenance, consent, and emissions very tangible, less sci-fi, more supply chain. Expect pressure for ingredient labels on models. Which data, whose labor, how much carbon. As domain-specific versions spread, knowing which model answered you may matter as much as the answer itself. As these systems spread into search, classrooms, and workplaces, the real skill won't be worshiping or rejecting them. It will be query literacy, knowing how to probe, cross-check, and combine their output with your own judgment. Your challenge this week? Pick one answer you get from an AI each day and actively try to disprove it. This was Owl Up, your daily step forward. To keep learning with structured courses and more insights, go to owlup.co. Until tomorrow!